All right, so a 20-gram ball hangs from the roof of a freight car by a string. When the freight car begins to move, the string makes an angle of 35 degrees. No way, and not for a freight car. Anyway, all right, with the vertical. What is the acceleration of the freight car? What is the tension in the string? Okay. So here's the roof of the freight car. And here's the ball. So they tell you this angle is 35 degrees. Okay. And okay, well, we'll draw the freight car. Even give it wheels. How's that?
It's a fine freight car.
There you go. Only for you, my friend. Only for you. Okay. So there's the acceleration. All right. So here's the tension in the string. And here's what the tension is having to do. The tension is having to balance the weight. So this component of the tension is balancing the weight. And this component of the tension is giving you the acceleration that you want. Okay. So we'll say here are the x and y components. This is 35 degrees. T. So the y component of the force is the ball is not accelerating in the y direction. So the net y component of the force should equal 0. So I can write that. Okay. So T cosine 35 minus mg equal to, actually let me, T cosine theta minus mg equal to 0. So mg, the x component of the equation, this is T sine theta. T sine theta is equal to m times a. Okay. All right, so what we'll do is, here's this equation 2. We'll call this 1. 1 divided by 2. Okay, so the mass of the ball cancels. Okay, that doesn't matter. It doesn't matter the weight of the ball. So tan theta equal to a by g. So a is equal to g tan theta. So that's the expression we get. Okay, you guys know the tan function. The tan function goes from 0 to infinity. Okay. So if this is your car and the ball makes an angle of theta equal to 90 degrees, then I want to be your friend. Your acceleration is infinite. Okay. And here's the thing: if the ball is hanging straight down from the roof, if theta is 0, tan 0 is 0. Your acceleration is 0. So here's the accelerometer. So this accelerometer is pretty good. Between 0 and 90 degrees, it gives you an acceleration of 0 to infinity. So that's the dial. All right. So let's calculate the acceleration of this freight train. Acceleration is g tan 35. So here's this acceleration, 6.86 meters per second square. For a freight train, there's no way in heck this is, even probably a Tesla doesn't have this kind of acceleration. Even a Tesla doesn't have an acceleration like this.
No, but even if it's turning, because turning will be acceleration, would it be able to achieve that?
You have to have super glue tires. So the joke is the fastest acceleration to achieve from a car is to drive it off a cliff. And when you're free falling, then so what is the tension? Now to get the tension in the string, the tension, of course. Can you tell me if this tension is greater than mg?
Yes.
Yes. Okay.
Because mg is downward force.
That's right.
That's the hypotenuse. It's going to be long.
Yeah. So from this equation, you can see that tension is mg divided by cosine theta. Okay. So tension is mg divided by cosine theta, and I want, so mg divided by cosine 35. And you guys can put in the numbers. Okay, so the tension in the string is 22% greater than the weight of the ball that was hanging from the string. Okay, you guys understand this? Any questions? Okay.
For tension, why do we decide to use the y component instead of the x component?
You could use either one.
Okay.
The y component, hang on a second, let me save the problem.